Okay, so we're going to solve this. This is what we call an eigenvalue equation. And what it says that when we multiply this matrix by xy, we get some constant multiple of xy. Well, that's equivalent to saying that, well, if xy is a solution to this, that's a vector that maps to that multiple of itself, just like what we've been looking at. So we've actually been looking at eigenvectors and eigenvalues before we even talked about them, okay? So, and you aren't likely to completely understand this, but this process is actually pretty simple, okay? Now, you might want to follow what I'm doing algebraically, but this says that 6, -2, 18, -3 multiplied by the vector xy is equal to, well, it's equal to lambda times xy, but of course, I'm going to write it this way. Because, of course, this is the identity matrix. If I multiply this by the xy vector, I get the xy vector, right? And the advantage to writing it like this is now I can write -2, not 0.2. Boy, that's going to lead me astray. Okay? This times the vector xy minus lambda. You know, to multiply a number through a matrix, you just multiply every number in the matrix by this number, right? So this would be lambda 0, 0, lambda. I'm going to kind of skip that step because it's fairly obvious if you understand the rules. And of course, we're doing an introduction here. If I subtract this from both sides, this is what I get. Because if I subtract this, this is just a 2 by 2, or this is just a column matrix with 2 entries, right? If I subtract a column matrix with 2 entries from itself, I get a column matrix with 2 zeros. Okay? And now I can write this as this. Because of an associative law, the fact that this thing behaves kind of like we expect it to, except for that little detail of commutativity. So I'm factoring out the xy on the right. Does that seem like a reasonable thing to do? If we understand how to factor out a monomial from an equation, in an algebra 1 type process, it's just totally analogous. And without having proven all the rules or stated all the rules for matrices, which we haven't done, I'm just going to say, except for the commutativity, they do about what we expect them to. Okay? Well, now, what do you think this minus this would be? Well, we do 6 minus lambda, -2 minus 0, 18 minus 0, -3 minus lambda, okay? In other words, we just do the subtraction in the way we would think, without justifying it, and we will justify it. But for right now, I'll say it works, and soon enough we'll learn how to distinguish what works and what doesn't. Okay? So we get this. Well, now there's a step that you're not going to understand. You're going to have to take my word for it. Okay? And basically, this can only be so if this times this minus this times this is 0. Okay, that's called the determinant of the matrix. And that just says that this row has to be a multiple of this row. okay? But the way we're going to state it is okay? Okay? Now let me show you the pattern of that, because it's this central pattern. Okay, it means if we multiply this by this, okay, and then multiply this by this, they've got to be equal. This times this has to equal this times this, keeps them proportional. Don't have to worry about that, just take my word for it. And that means if we subtract this from this, we're going to get 0. Okay? So it's really that simple. We don't have to worry about that. Right now, just remember that if we do this times this and subtract this times this, we got to get 0 and it's going to work. Okay? Well, if we multiply this out, what do we get? We get lambda squared, and we get, let's see, minus 3 lambda, minus 6 lambda plus 3 lambda, which is minus 3 lambda, minus 18 plus 36 equals 0, right? And that gives me lambda squared minus 3 lambda plus 18 equals 0. Okay? Now, can you solve that for lambda? Well, you know, you might be a little rusty. If you're a little rusty, you solve it in one of two ways. You can factor this, and this does factor, but what do you do if it doesn't factor? Use the quadratic formula. Okay? So if you don't know the quadratic formula, don't let it be so on Thursday, even though I'm probably not going to test you on it Thursday. You want to have the quadratic formula down and not have to worry about it anymore. Okay? Now I will say, I went to school of science and technology and engineering, didn't offer any courses below calculus. And I hadn't had pre-calculus. It made a real adventure. I figured it out. Just barely. Okay, but I knew the quadratic formula. One reason I could figure it out is I had extraordinarily solid algebra, better 80% of the people that were there. The other 20%, forget them. You're never going to catch them. Okay? And I think the majority of people in my calculus class didn't know the quadratic formula on the first day. Okay? So if you don't know the quadratic formula, I'm just giving you an excuse. Okay? You've got good company. You've got, you know, people at a top-notch technological institution back in the days of the space race, where the majority, I think, didn't know it. And I was in a kind of an, you know, I don't know, I had high SATs. So they put me in a course with a real professor instead of a graduate student, and higher expectations. I wasn't in the advanced course, which is for people who'd already had a calculus, okay? And even people in that course, a majority of them, I don't think knew the quadratic formula on the first day, okay? So I'm making it even better for you if you don't remember. But if you do, it's much to your credit, okay? Especially if it's been more than a couple of years. Yeah. got a feather in your cap if you remember it, but the next time make sure you know and know how to use it, right? Okay, fair enough? Anyhow, we go on to solve this. Well, the easiest thing is by factoring. Lambda minus 6 times lambda plus 3 equals 0. And the only way that can be is if either lambda minus 6 is 0 or lambda plus 3 is 0. Because one of these ain't 0, their product ain't 0. Okay? And then that tells you lambda equals 6 or lambda equals 3.
Negative 6 times 3 is
Negative 3. Yeah. If lambda is 6, that makes this 0.
Right. If you multiply
Uh-oh,
this
wait a
out-
minute. That's
Yeah.
plus 18. Something's
Yeah.
wrong.
Should have been negative 18.
Well, there are...
Yeah.
Plus 36.
It's the
Okay,
minus.
something's wrong here. We're going to fix it.
Wait,
You know.